The second topic of this course is timers and interrupts. So first I will go through the PSoC interrupts, how they actually are working on the processor level, and then also how they are implemented on the creator, then something about the timers, and then some information about PWM and servo motor control as an application. So let's go and take a look at the PSoC interrupts. And let's see, there we go. So, PSoC interrupts are basically on 5LP. We have this 32-bit ARM Cortex-M3 processor. It has 32 interrupt inputs, meaning you can have 32 different interrupt service code segments on the system and 32 interrupting things. Actually, you may have these multiplexed sources, so there are at least enough of these the interrupts available. So what is special for this compared to anything else? Well, actually most of these are just the same on any other big processor, so configurable interrupt vector address compared to small processors like 8051, which has certain specific interrupt vector address, meaning the addresses where the process jumps when interrupt appears. This one actually have an interrupt vector table, and the interrupt controller takes care of the vector address. And on this ARM processor, basically there's a flexible interrupt sources. So basically you can actually have the fixed function, meaning some of these fixed properties which are on this processor CPU level, DMA, direct memory access, may have one interrupt source, or then we have these UDBs, universal design blocks. So practically any signal source you design on your PSoC creator actually can be as a interrupting signal. Two types of interrupts depends on either if you have the level triggered, which means that if your interrupting signal goes high for longer time, then basically you may have several interrupt service calls. So basically if there are interrupt service calls as long as the state is high, or edge triggered, which means that actually the each of these events will be treated as one separate interrupt service routine call. So basically on this other example here, where we have this the same interrupt or lower level interrupt actually comes on during the interrupt service routine here. There is a lower level interrupt coming, or lower priority interrupt coming, then basically it will be pending until the process goes back to the normal, and basically that's when the following interrupt service routine starts. So two choices, or actually on the creator there are also the third choice. More about that on the creator. Interrupt support actually on the design software, the PSoC creator. So there is actually instance named interrupt component, which is under catalog, and under there's a system, and there actually is an interrupt. You can then connect to any signal source. I/O, fixed functions, UDP, DMA, you name it. And then there's a configuration tool to rename and select triggering method. So if it's edge or state or derived. 8 different interrupt priorities, which can be selected for each interrupt service routine freely. There are some default values, and it takes actually some work to set the priority by yourself, but actually there's excellent instructions for that one. Basically a point-by-point instruction on the application notes. Interrupt service routine source code is generated automatically, and there is actually a pre-written code, a Cypress ISR function. Well, it looks like function, but actually there are 2 lines, start and end, so you can actually edit your own function there, the functionality for this interrupt service routine. And then basically what you need to do to get this interrupt service routine running is you just call a function which starts that interrupt. Okay. There is also a way to define your own interrupt service routine for example, at the end of the main file. More about that on Cypress application note marked here. There's also a link. Some reminders about the interrupts. So practically one of them is the optimization. Avoid function calls in the ISR. So basically they will only add you some the overhead and increase the latency of the interrupt service routine calls. So basically the right way of doing interrupt service code is you use locks, mutex, semaphores and then some nice coding, and do as little as possible in the interrupt service routine call. Do only the time critical or event critical things, like changing some these signals. For example, some semaphore, you just change the value of it. Then another one, use proper priority to the interrupts. Okay, so if you have time critical, then you need to put those on higher interrupt level, meaning lower interrupt number. So 0 is the highest priority and number 7 is the lowest priority interrupt. So user code basically should be at level 7. Say communication, depending if it's time dependent or not, should be, say, somewhere in the middle. The system maintenance requirements on higher, say maybe 1, the level 1, and then highest should be used only for very critical things, like if you have a critical time on A to D converter or something like that, maybe then you could use the 0, or well, some say some error situations handling. So if you want, if you need to have a, for example, kill signal for the process, so that if, for example, your engine doesn't overheat or something like that, then of course that should be the highest level interrupt. Okay, then of course interrupt component has API. Read the datasheet. really read the datasheet and try to understand it. There's plenty of stuff there. You may actually also need to read this application note on this one here, Cypress application note AN54460, which is about interrupts overall. Read the interrupt component API. Saves you lots of trouble and saves you a lot of time on making the exercise. Notice that some of the components already have an interrupt component inside. So a component has already a interrupt inside. Okay, again, read the datasheet how to actually then use that interrupt code. Can you edit, or is it just something that is provided? Interrupt latency, okay, on Cortex M3 it's 12 cycles. It's not much. So basically that much time it takes to jump at the middle of from the middle of the main to start the new the interrupt service. And I think interrupt latency actually also have the return time there. But of course you then need to add some code there that'll increase the time it takes during the interrupt. Okay, but just a small detail. So if you are really fast things what you are doing, then you probably also need to count these. Debug. Okay, this small board what we have has this debugging tool available. Learn how to use it. It's also something that actually saves you a lot of time. So on the last on the previous topic actually I was showing the some hints how to set these breakpoint and how to run a debugging mode on your device. That actually helps you a lot on the designing your code. Okay, that was the short version of the theory part or lecture part, whatever we call it, on how the interrupt services actually are working on the PSoC, and especially PSoC 305. Next, actually, let's take a look at how a simple timer interrupt works on this PSoC environment. And this is almost directly the same as is on this interrupt service, the application note. So you might have also try to do it from the application note. But anyways, I will do a separate the video for the timer interrupt. I will show you now just where to find this interrupt on the PSoC creator. So let me open, for example, okay. I will open this yesterday's exercise what I was working. Well, this is not complete as you see, but anyways, let's also learn first how to actually make a save this project as let's see. Okay, yeah, to template. So I can actually copy this project, my tested project, to my templates on the creator. And next thing, if I close this workspace and create a new project, I can continue it from my template project with the top one here. Next. And okay, I have this funny place here. And new would be, for example, exercise 02 project name, exercise 02 or something like that, or actually just 2, exercise 2, finish. Okay, yeah. So as you can see, this is not a complete complete design. Anyways, that could be used for debugging. But anyways, to have a let me take that. Let's see first. Ports and pins. I will take a digital input pin. What I had yesterday. Configure it as button. Name is button. No hardware connection. And resistive pull up. And starting from initial state high 1. Okay, that's what I did there. And okay, and basically now let me connect it as a with the hardware connection. Now I can take this button and run a run interrupt service routine from that one. Interrupt. There we go. Great. So now I just need to this name, actually the interrupt service routine 1, that's just fine. The ISR1, it's just fine. It could be also, if it's only for this button, then you call it button ISR, but it's up to you how to name it. Let me add some wire tool, and there we go. Oops. Let me do it over. There we go. So now there's a connection from button to interrupt service routine component. Okay. So when I press the button, it actually, the state goes low. And here you can change the name, and then also is it the derived or rising edge, or is it level interrupt? Okay, actually this should be probably rising edge, although this derived means that in first the interrupt type based on the signal source, and now we have pull up, so I would guess that this would be then interrupting on the blowing the down going edge. On the other hand, if you have a button interrupt, so it's not a big deal if it's going up or going down kind of interrupt. Let's click on the derived, and let's take a quick look on this one. Okay, nothing here. There, sorry. So then actually it's derived on, so on the component interrupt service routine now is derived. And now we can actually have either rising edge, falling edge, or both edges interrupt. There we go. Threshold, well, the CMOS is just fine. Apply. Okay, then actually let me change that one, since the interrupt service routine actually have its own signal, which means that we do not need this hardware pin there at all. Okay, sorry about that. I didn't quite understand. I can't quite remember how it actually goes. I was actually talking about it. So the digital input pin component actually already have a interrupting component inside. You just need to turn it on here, either rising edge, falling edge, or both edges. And then you can use the interrupt service routine link from this interrupt request right here. Okay. And there we go. So that's the, now it's interrupt service, the code is now the hooked. Okay, so let's see what happens when I generate application. Yeah, of course something is missing here, like setting the pin button is not port 0.0 but port 2.2. There we go. Good. Let's generate the application again. Okay, so we have again lots of code here. Also main file. So there we have a global interrupt 1 enable. In addition to this one, actually we need to also enable the actually turn on the ISR. So actually that's the ISR 1 start. There we go. So that's the only thing what we need to do to turn on the interrupting service routine. Okay, which is currently, well, quite empty. Okay, since the code itself is here, ISR underscore 1, and there's ISR 1.c. There we go. So okay, wow, there's a plenty of code. If you need to have any includes, defines, or some global variables, you can put them here. For example, you can actually have a signaling a flag kind of variable, which is a common variable for this, and or global variable, which is actually set here and read on this read on the main file. Okay, there's this, but there we have the okay, it doesn't mean that one, but one stop there. This is actually the CY ISR, and the code segment should be here. Whatever you want this interrupt service routine to do, you can put that code here. I will give you here a little bit more hints than I need to. So for example, you could have a global variable here. Button pressed, which I define to 0. Okay, and in this code here, let's go up. We have this path which does not change when you click the we can actually have that variable defined as extern button pressed there. Inside of the interrupt service routine, you just changed button press to 1, for example. This would actually then work once. One important thing to remember on the interrupts, there's also the pending mechanism. In order to tell the processor or the interrupt controller that this interrupt call was already served, then you need also to clear that interrupt, and that you can find from the how to clear that interrupt actually on documentation, on the pins documentation. Application programming interface interrupt. Constants. I think you need to, okay, where is the okay, general API functions. Clear interrupt. Okay, you need to also say button clear interrupt at some point to clear it. Okay, in this example I could do it so that if the button pressed is actually changing the value here. Let me compile that one. Okay, does it compile? Okay. Yes, and here actually we will do, well, for example, inside of the loop, if button pressed, so the execution goes here only if I manage to get the interrupt code working. This is just to keep track on these brackets. Then I could do here whatever, do things, and then clear the button pressed flag. So this is software flag, and then button clear interrupt. There. So that would be just perfect code. Okay, so let's start again from the top design. So I have the button and I configured the button also to interrupt on both edges. So actually this one would the interrupt on when you press it and then when you release it. Then when When that is done, then you can actually hook this one into the interrupt component. I added the interrupt component, which is now ISR1, which then actually have also the then it's source code where you can edit. So if I want to have an interrupt service call doing something, then basically I can edit in this isr1.c. I can edit, add here, for example, this kind of global variables, and also I can edit this ISR1, where was it? CY, yeah, here, the interrupt service code, where I can change that global variable and then check on the main that global variable, which is, I think this could be called as this is basically using a variable like, not really mutex, but more like a semaphore. So yes, button pressed. I can check it, clear it. Okay, it was pressed once, but then in order to enable that interrupt service routine again, you have to actually clear the button, not button clearing, yes, button clear interrupt, yes. Otherwise it interrupts only once. That's how this system actually works. Okay, more about this general topic of timers and interrupts on my next video.